Okay, in this video we're going to look at an example from 2003. I'll even insert paper. In this question we know the value for Kc, we know the value for the equilibrium constant, and we want to try and find one of our concentrations at equilibrium. Okay, so if we rewrite our equation, we have H2 plus I2 and you have 2Hi. Okay, so the value of the equilibrium constant Kc for this reaction is 50 at 721 Kelvin. If 2 moles of hydrogen iodide gas were introduced into a sealed vessel at this temperature, calculate the amount of hydrogen iodide gas present when equilibrium is reached. Okay, so we have Kc is equal to 50. Okay, if we look a little more to see what that actually means, it means Kc, which would be Hi squared over H2 and I2. Okay, and that equals 50. Okay, so if we look and create one of our ice tables, so you have initial, change, and at equilibrium. Okay, so initially we have that 2 moles of this hydrogen iodide gas are introduced. Okay, so here you would have that you initially have 2 moles of this. Okay, at this point in time you have 0 and 0. Okay, your change then, alright, here again we're assigning a substitute, okay, for whatever the change is. We're not sure what the change is, so we're going to say that it is x. Okay, so we're going to assign x as our unknown. Okay, our ratio across here is 1 is to 1 is to 2, so it's not 1x here. We actually are going to lose 2x. Okay, here is just 1, so we're going to have plus x and plus x here. Okay, and we're trying to find the concentration then of these. Okay, so we look back up here again at our Kc. Okay, and we're going to sub these in to what we have. Okay. Alright, so at our Kc, okay, again we have products on top. Okay, so this is going to be 2 minus 2x. Okay, and it's going to be squared. And underneath then we're just going to have, okay, so that's x squared. Okay, if we want to get rid of, okay, we've a square above and below the line, so we can get the square root of the whole thing. Okay, so that's going to get rid of them for us. It's going to be 2 minus 2x over x, and that comes out over here to be 7.07, because we have to find, if we find the square root of this side, we also have to find the square root of our 50, which is roughly 7.07. Okay, again, working out for x, x is going to come out to be 0.22. Okay, it's just maths that you have to use there in order to come out with your 0.22. Okay, so that's your value for x. Okay, so your x value is equal to 0.22. Okay, so over here you're going to have plus x, so at equilibrium you're going to have 0.22 moles, 0.22 moles. Here you're going to have 2 minus 2x. So you're going to have 2 minus 2 multiplied by 0.22. Okay, that comes out to be 2 minus 0.44. So at equilibrium, you're going to have 1.56 moles per litre, okay, of this hydrogen iodide gas. Okay, and in your actual exam paper it may be no harm to write that at the very bottom, okay, underneath all of this, that you actually worked out the concentration down here as well.